Hey, welcome back to Math with Patrick. Today is January 10th, and we are solving the 10th problem in this Daily Epsilon calendar by the American Mathematical Society. Well, let's get into it. Today we just have an equation with an x, and the assumed instruction is that we need to solve for it. Of course, we already know the answer is 10, but we just have to prove that 10 is the number that works. Okay. I don't really like how it's written in two rows, so what I'm going to do first is just rewrite the whole question. And as I'm doing this, what I notice is that all of these fractions have an x attached to it. And so it's like I'm adding up parts of some mystery number. And once I've added and I guess subtracted some parts of this number I don't know, I'm going to end with 8/9. And so my goal here, I think, is I want to collect up all these like terms and have just one fraction in front of an x. Like I'd like it to be something times x is 8/9. That way I can just simplify the left side and make my thinking and my problem solving process just a little bit easier. An issue here is that all of these fractions have a different denominator, and you can't really add or subtract fractions from each other when their denominators, or these bottom numbers, are different from each other. And I guess a picture explanation as to why is that if I split something up into thirds, and then I split something up into halves, and I asked you to add 1/3 to 1/2, I mean, sure, you could stick it together up here, but how high does that really go? It's kind of hard to tell when you have different denominators. So a strategy is to find a common denominator. If I split these things up into sixths, it's a little bit clearer to see how they add up. Now I can see that 1/3 is the same as 2/6, so I could put two of these up here. And here's a picture proof to show that 1/3 plus 1/2 is equal to 5/6. And so it is important to be able to find some common denominator. In this case, that common one was 6. So I'm going to have to do a little bit of work to figure out what is the best new denominator to create for this problem. And this example shows me a strategy I could use to find a common denominator. I know that 3 times 2 is 6, and so something I could try is just multiplying all these denominators together, and it will work. It will give me a number that I could then use as a common denominator, but it's going to be really big, and I'd rather not use big numbers if I don't have to. So instead, I'm going to offer another strategy, and that's going to be to find the least common multiple of all of them. And let's break down that term least common multiple, starting with the word multiple. What does that even mean? Well, it means starting at any given number, let's say 3, and if I multiply it by an integer, I can get a multiple of 3. In other words, you can just kind of count up by 3s, and you're going to get a long list of multiples of 3. So here are the first few multiples of 3. And I could do the same thing with 5. And so here's 5, and I can list the first few multiples of 5 by just counting up by my 5s. And then going back to the idea of least common multiple, the common part means that I have two lists here, and I find some that they have in common. So this 15 is in common. And if I kept counting up these lists, eventually I'd get 30, which is a multiple of 3. And I'd get, 30 again, and that's a multiple of 5. So here I found two common multiples. And between the two, 15 is the least, or the smallest. So I just found the least common multiple of 3 and 5. That's going to be 15. And, actually 15 is already in this list of denominators that I'm considering. So if this 9 weren't even here, then I would want to change both of these to 15s, and then I could continue with my problem of adding and subtracting fractions. But this 9 is here, so I think what I'll do next is find the least common multiple between 15 and 9, and that's probably going to be good enough for finding a nice common denominator for my fractions. So I'll count up by my 9s, 9, 18, 27, 36, 45, 54, and so on. Then I'll count up on my 15s. 15, 30, 45, 60, and oh, actually, I could have stopped a little bit sooner because these 45s line up, and there isn't anything earlier or less than 45 that's going to line up between the two lists. So 45 is a multiple of both, so it's a common multiple, and then it's also the least one that I found, or the smallest. So 45 is my least common multiple, and now I'm going to start trying to convert those fractions earlier to ones with a denominator of 45. And to do that, I can figure out, well, what do I need to multiply the denominator by? That was a times 3. And to keep my fraction having an equivalent value, I just need to multiply my numerator by the same amount. So the bottom multiplied by 3, so the top needs to multiply by 3 as well. And 14 times 3 is 42. So here's that x still from the problem, and I'll keep going. I still want that common denominator of 45, and so just so I don't forget, I'm just going to write that down first for all of them. So I'll keep converting the fractions. 3 times 15 gets me to 45, so I know that I need to do 2 times the same 15, so a 30. 5 times 9 gets me to this 45, so I need to do a times 9 here, 27. 9 times 5 gets me here, so I need another times 5. That's a 35. And then finally, oh, it's 9 again. 9 times 5 is 45, so I'll do 8 times 5, and that gets me to 40. There we go. So I found a common denominator, and now I can add and subtract my fractions. When adding fractions or subtracting them, you only really need to look at the numerators. I know that 42 minus 30 gives me a 12. 27 minus 35 gives me negative 8. And so it looks like when I combine all of these together, I'll get a 4 on the top and a 45 on the bottom. And then can't forget that x from all of them. And that will be equal to 40 over 45. Now, one thing I'll do here is I'll multiply both sides of this equation by 45. I'm kind of treating it like an algebra problem now, just trying to isolate this x. So let's see, I'll do that step right here. I'll go times 45 times 45. And the idea here is that I just wanted to remove those denominators and just look at the 4x equals 40. And now I can tell that if I sub in a 10 right here for x, then this equation is going to be true, because 4 times 10 is 40. So that's it. I have solved this problem. I know that x is equal to 10. I mean, I already knew that from the get-go because it was here in the corner, but this is me showing that the answer indeed is 10. Well, thanks for coming along for this ride and solving this problem with me, and I'll see you tomorrow. Bye!